Hi, standoff. Good evening, or almost farewell. So great that you've been with us for these 6 days. And let me use this opportunity to thank everybody who organized and participated in this event. And this is a closing presentation for those of you who want to read news in, say, Safari. Let's listen to Nikhil Mittal to tell us about hacking adventures with Safari Reader Mode. Stay tuned.
Hello everyone, welcome to the talk My Hacking Adventures with Safari Reader Mode. My name is Nikhil. I work at Payatu Labs and I am into web and browser vulnerability research, basically everything that relates to the client-side security stuff. I've also spoken to a few conferences such as 36C3 and PS Days 9. So let's talk about the web of distractions, or we can say the today's web. So if you are using web, you might have came across a situation when there is a nice article on the website fully loaded with different advertisement, funky background images and sounds. So sometimes it is very frustrating to read the article when there's a weird pop-up comes to your screen, or a video starts playing in the background, or the website start requesting different permissions such as notifications. So to deal with such situation, browser vendors came up with an idea of using reader modes in browser. So reader mode is a feature implemented in most of the browsers that allows you to read an article in a clutter-free view, basically rendering a page without any distractions like advertisements, background images, etc. And so Safari also comes with the built-in reader mode support since 2010, which is available for macOS and iOS devices, which effectively removes different advertisements, navigation, and it creates a nice clutter-free view. And the same thing is being claimed on the official website as well, which says you can hide ads when reading articles in Safari Reader mode. All you have to do is to click on the tiny lined up icon, which is available at the leftmost corner of the address bar. So for me, it was pretty interesting to explore the security of reader mode because it creates a totally different DOM representation than the actual one. So I started exploring the Safari Reader mode and different functionality. So to start the test, I take an example of simple HTML page, or we can say that a ugly HTML page, which has a heading which says macOS, and it is there nothing like a Mac, followed by 4 paragraphs, and the content is being taken from apple.com, and so there is a link to apple.com. And after that, we have 3 iframes, which is pointing out to bing.com, and at the end we have a simple alert1 string. So let's see what happens as soon as this document turned into the reader mode. And as expected, Safari creates our ugly document, or Safari turned our ugly documents to a very beautiful document, which is pretty formatted and clutter-free and easy to read. So let's talk about the working of reader mode, or the Safari reader mode in action. So as soon as any normal document turned into the reader mode, Safari removes the iframe, different embedded elements, and also the objects. It also removes different JavaScript event handlers to make sure there is no JavaScript code execution at all. And at last, it applies HTML and CSS to beautify the content. Now, if you scroll down our ugly document, which turned into a beautiful document, you would see that our iframes, which was pointing to bing.com, is been removed, and this was expected from the Safari reader mode. But what was interesting is that a hyperlink which is pointing to apple.com remains same. So this gives me an idea of executing scripts in Safari Reader mode, because if we can execute scripts in Safari Reader mode, then we can present any sort of distractions or advertisements to the user, which will ended up breaking the Safari's promise to the users. So since we know that the hyperlink is getting rendered into the Safari reader mode, the next idea was to create a hyperlink which is pointing to a JavaScript URI, and let's see what happens. So as soon as this link is rendered into the reader mode, Safari removed the hyperlink and turned into a normal tag and turned it into a normal tag. So somehow Safari is feeling, or Safari is smelling an attack that we are trying to do something evil, and that is why it removed it. It removed our hyperlink, which was pointing to the JavaScript URI. So next, I started looking for different ways to fool the Safari to think that we are not even using any JavaScript URI. And the first thing first is to use the special 5 entities between the JavaScript keyword, such as &tab, to fool the Safari and to make us think that we are not using any JavaScript URIs at all. And surprisingly, it works for me. So now if we use this particular payload, and as soon as the document is rendered into the reader mode, you would see that it will create an hyperlink which says evil link, and which is pointing to the JavaScript URI. And as soon as the link is clicked, we should get the alert one, right? But this was not the case. As soon as I click on the evil link, nothing has happened. So most of the browsers, such as Microsoft Edge, Mozilla, and Chrome, comes with the built-in CSP support, but built-in CSP support. So I tried to open the developer console to check if there is any CSP error, but surprisingly, there was no CSP error at all. So this surprised for me also. I thought there is another challenge to figure it out. So next, the idea was to use an invalid function after the JavaScript URI. And so if we receive any error in the console, we can conclude that browser is actually interpreting our JavaScript code, but it is not allowing us to execute some sort of JavaScript functions. So I decided to use this particular payload, which is pointing to a JavaScript URI and then an invalid function. And as soon as it gets rendered into the reader mode, you will see that once the evil link is clicked, we have a nice error which says reference error. It cannot find variable invalid functions, which means now we are sure that browser is actually interpreting our JavaScript code, but we cannot use some sort of defined JavaScript functions. So after digging a bit, I figured out we can at least use the console.log and the window.open method inside the reader mode. So I created a simple proof of concept which uses a window.open method to alert the location of current window as soon as the evil link is clicked. And so as soon as the link is clicked, you will see that we got a pop-up with the current window location which says safari-reader lab.com. So the interesting thing to note here is that the origin starts from the Safari-reader, and which is a procedure protocol used in Safari reader mode. So this was pretty interesting. Now to think of a way to break the Safari promise, what we can do is we can create a lot of distractions. So for instance, we can create an image which should move around the screen using the marquee tag as soon as the evil link is clicked. So again, this will create a moving pumpkin image on the user screen, which is again pretty frustrating, and this way we can break the Safari promise. So apart from that, the interesting thing is the next challenge was to look for different vulnerabilities like UXSS or SOP bypass because of the different origin which we are in. But sadly, there was no success. I tried a lot of test cases to found any of the related issues, but I failed to do so. I completely failed to do so. But at last, I figured out that this can use to bypass CSP checks in Safari reader mode. So for instance, assume a situation when an attacker is able to inject any JavaScript code on a website which has a nice CSP in place, which says default src self. That means every content is allowing from the same website, and again, we are using our anchor tag payload, which and which pop-ups the current window content on the page. So now in normal mode, if you click on the evil link, you will receive a CSP error as displayed here that there are some CSP issues and Safari is not letting you allow you to execute the JavaScript code. But as soon as the document is turned into the reader mode and if you click the evil link, it will prompt us with the page of content, which means that we have successfully bypassed the CSP checks. So now this vulnerability was fixed in March 20 update by Apple. So once the patch is released, I decided to look at the Safari reader mode again, and so we bypassed the last check with this following payload. So first thing first, I started to use different kind of HTML entities in between to check if we can somehow bypass the patch. Also different types of encodings, but none of them worked at all. So there were other improvements as well from the last time, and so I've tried a couple of other methods as well, but none of them was working. And then at last I decided to play with our good friend SVG. So I created a simple inline SVG script which uses an element called as circle to figure it out if it's get rendered into the reader mode or not. And surprisingly, the harmless SVG was removed from the reader mode and Safari did not even consider it. So the next moment, I decided to try a couple of other methods as well. So the method which works for me was the text element because the text is something which Safari is more interested in. So I rendered this particular SVG element and this gets rendered into the Safari reader mode as you can see that. So now since we know Safari is actually taking the SVG part, now we have to look for all the possible combinations to execute scripts using the reader mode. So the first thing first is to use the scripts inside the reader mode, and as soon as it gets rendered into the Safari reader mode, Safari just removed the script and rendered the rest of the part. So somehow Safari is again smelling an attack, and that is why the scripts were get removed. Also, the same attempt is being done using the event handlers as well. So since Safari is considering the text element, the next idea was to append the event handler with that. But again, Safari did not consider the event handler and displayed rest of the content. So again, Safari is yet playing smart. So at last, I again try to use or try to hyperlink the text element, which was getting rendered before. And so this time again, it worked for me. And not only the text element, but also a hyperlink to the circle element was getting rendered into the reader mode, which was not even considered by the Safari before. And so as soon as the particular document renders into the reader mode, and if you click the black icon of black circle of SVG image, we have the JavaScript code execution again, which displays the message blah. So now you found a bypass. What will you do further? So now again, this time I challenged myself to look for different possible attacks or different possible test cases which was not covered before. And so I started playing with the iframes. Now you might be wondering what is the point of playing iframes in Safari reader mode, because they were the first thing which will get removed by the Safari reader mode as we discussed previously. But the main idea was to check if Safari imports any content such as text, images, etc. from the embedding iframes as soon as the document turned into the reader mode. And that being said, I started playing with the iframe, so I came across different test cases. So let's study a few of them. So case number one, when we have a simple document which has 4 paragraphs following with a iframe which is loading from the cross origin evil.com, and it has a frame border which is set to 1 pixel. And this is the content of secret.html file which is getting loaded from the evil.com, which has a lot of p tags. And this is how it looks in normal view as soon as we open this particular document in Safari. Now let's again render this document into the reader mode to check what happens. And so as soon as the document is rendered into the reader mode, you would see that the iframe is being removed, which was pretty much expected by the Safari. So again, let's study another case when we have a little variation here. The only thing which is changed from the first case is that we have defined a custom height which says 600 pixel and a custom width which says 1200 pixels to an iframe. And this is how it looks as soon as it renders into the normal mode. And so again, let's try to render this document into the reader mode, and again Safari removed the entire iframe. So let's try one more time. Again, the idea was, in case 3, the idea was to keep less content on the top frame, and which is why we have only one paragraph at the top frame, and more content from the child frame, which is the secret.html file, and the height and width remain same. So this is how it looks in normal view. So now we have only one paragraph at the top frame, and rest of the content is from the child frame itself, which is loading from the evil.com. And as soon as it gets rendered into the reader mode, the document is turned into like this. So did you notice something weird right here? Well, if you noticed, the document is taken from the top frame while rest of the content is taken from the secret.html file. Like what? Maybe Safari is drunk, or maybe Safari is trying to do something else. Who knows? So let's figure it out. So after digging a bit, I figured out that it either takes the title from the top frame, or the H1 element or the H2 element from the top frame, and rest of the content is taken from the iframe, which is getting loaded from the evil.com. So let's again render this document into the reader mode to prove our statement, and as this document is rendered into the reader mode, you will see that we got a first H1 element on the top frame, which is being taken from the top frame, and again rest of the content is from taken from the child frame. So let's talk about the same origin policy in browser. So every modern browser comes up with the same origin policy, which restricts the interaction between the cross origin frames. And so for instance, you can assume a situation when you have your bank.com open in one of the tab, and in another tab you have evil.com. So now if evil.com tries to read or try to fetch any of your banking details or bank related information, browser will not allow it to do so, because they both belongs to the different origin. Now the same case with iframes as well. So for example, we have the top frame which is loading from the lab.com, and the child frame is getting loaded from the evil.com. So again, if we try to read the content of child frame from the top frame, and since they do not comes under the same origin, browser will not allow us to do so, and so we will get a SOP violation error which says, for being in same origin, the protocols, domains and ports must match. And same as vice versa when you try to read the content of top frame from the child frame, that is reading the content from evil.com to lab.com. So let's consider an example again. As we have witnessed that Safari either took the content of H1 element, H2 element, and also the title element. So for instance, we have a heading which says welcome to secretemail.com, and the H2 element contains one of the value from the mail, which says you have got $1,000 PayPal cashback. Your coupon code is this. And again, it has a simple iframe, and this is the content of the evil.com or the evil ad website, which again has a simple SVG element, which loads the circle element, which is hyperlinked to a JavaScript URI, and as soon as the element should click, it should pop up the content from the H2 element or the H2 tag. And so this is how it looks when it gets rendered into the normal view. Again, we have a heading right here, and then in H2 tag we have the cashback code, and then inside an iframe we have the SVG element. And so as soon as this document is rendered again into the reader mode, you will see that this is being taken from the top frame, this is from the top frame, and rest of the content, this is taken from the child frame as well. And again, as soon as you scroll down to the document and click our SVG element, which is a black circle, you will get a pop-up with the value of H2 element, which again says you have $1,000 PayPal cashback, and this is your PayPal code. So now this was the first success in bypassing the SOP. So now again at this point in time, I was also very curious to know if we can somehow reverse this process. So till the time we have witnessed how a child frame can access the content of top frame, and since a child frame can access the content of top frame, which means you can read the top window location, which might contain any session token or CSRF token or any unique token based on the website functionality. Also, you can change the content of top frame, which can create some sort of misinformations or phishing related informations and whatnot. So I try to reverse this process. That is, I try to read the content of from top frame to child frame. So since we already know Safari is already taking either H1 or H2 values, so I decided to place our simple SVG element inside the H1 tag to see if it gets rendered. And again, as the document turned into the reader mode, nothing has happened. Safari just ignored our H1 element, and it is just fetched the top frame title, and that's it, and rest of the content is taken from the child frame as usual. Now the next test case is to add some sort of strings inside the H1 element, which says the H1 on top frame, element on top frame, element on top frame, and then again our harmless SVG tag, and then again our SVG tag, which is pointing to a JavaScript URI, which should log a message called as blah. So again, the document, again the SVG is being considered by the reader mode. As you can see that we have the SVG element, but the weird thing was that now the href is pointing to some of the SVG property from the reader mode, which says object SVG animation string. And as soon as you click on that, you will be landed on a non-existing page. So this is of no use for us. So what do we do now? We have the SVG element. We have it pointing to the JavaScript URI, but it is Safari is adding its own property to the href, and maybe this is something predefined by the Safari, because again it is spelling some sort of attack. Now after again digging a bit, I figured out that if we place our SVG element before even closing the H1 tag, that is, this is the opening of H1 tag, and before we close it, we should place the SVG element that we have. So let's see what happens when this particular code gets rendered into the reader mode. And as you can see that as the code is rendered into the reader mode, now we have the SVG element, and again we have the href, which is pointing to the JavaScript URI, and as soon as the link is clicked, or as soon as the H1 element is clicked, we have the JavaScript code execution again. So which means now we can bypass or we can read the content of top frame to child frame as well. So now we have covered both of the cases. So during this research, I also stumbled upon interesting fact, which is the location.hostname behavior. So location.hostname is a property which gives you the current host you are on. So if you check the value of location.hostname in Safari Reader mode, which says the lab.com, because this is the current domain we are on. So now the interesting behavior was that you can change the location.hostname to any cross origin, and Safari just accepts it without any redirections. So let's see how it works. So initially I tried to change the value of location.hostname to a cross origin which says https apple.com, and hence while checking back the value of location.hostname it remains same, which is lab.com. So nothing is being changed. Now the next idea is to check other possible combinations as well, and after digging a bit I realized that any string which has a semicolon is not allowed, which means any host pattern which relates to x colon x should not be allowed by the Safari Reader mode. And as you can see here, initially we have the location dot host name which set to the lab.com, and again we are setting location dot host name to a pattern colon x, and again if we check the value of location dot hostname property, it remains same, which is lab.com. Now again, we can also use a valid host pattern like /apple.com, and since it does not have any semicolon, it should be accepted by the Safari. But again, this was not the case. So as soon as I set location.hostname to /apple.com, and if I check the location.hostname again, Safari sets the origin to the blank. So after all of these attempts, finally I decided to use a valid hostname value which does not have any protocol, does not have any semicolon, and also the double slashes. So which is simple, just the apple.com, and it accepted by Safari. So it gave me some joyful moment until I realized the location.origin, which is set to the Safari-reader apple.com, which means the SOP will be a big evil here, and it will not allow us to access anything over http apple.com or https apple.com. Also, at this point in time, I try to check if we can access any values that belongs to apple.com in the reader, inside the reader mode, in the local storage or session storage or the cookies, but they were completely isolated. So you cannot access anything over the local storage, session storage, or even the cookies while you are in the reader mode, even though you have changed the location.hostname to the apple.com. So now, then I remember a blog post from Apple Camera Hack from Ryan, and which gives me an idea that Safari does not track the websites, currently active websites, or the permissions of the website based on the origin, but else it uses its own observations. So for instance, you can see that we have 3 websites open. The first one is httpslab.com. The second one is also httpslab.com, but in the reader mode. The third one is simplelab.com. And if you check the currently open website, so it says there is only one website, which is lab.com. Now, whenever you try to download any files from the website, or a website tries to download any files to your system, Safari will prompt you a dialog which says, do you want to allow downloads on particular website? And if you click allow, then you are allowed to download files, otherwise you are not. So once you click allow, from next time onwards you can download any files from that websites without any prompt, or Safari will not bother you to ask you again. So for instance, let's suppose the apple.com is already added as a trusted site in our victim's browser. So what we can do is we can run a simple script which sets the location.hostname to apple.com, and And again, as soon as the location.hostname is set to apple.com, we are dynamically creating a link which is pointing to a DMG file. And again, the link is itself getting clicked after 2 seconds. So after 2 seconds, a file will automatically gets downloaded into the victim's browser. So this is how you can bypass, you can manage, I managed to bypass the download permissions. And similarly, you can bypass the pop-up permission as well, which is again setting the location.hostname to apple.com, and again creating or popping up a new window. So this was it. Now the another interesting fact is that all of the other permissions such as video, audio, screen share or geolocation permissions, they are available only in secure contexts or browsers. And by default, Safari Reader mode is considered as an insecure origin. Even if you check the window.isSecure context, it will return as false, which means this is not the secure context. So we cannot request other permissions such as the audio, video, and screen share and geolocation permission. So now that again a task, the next task or the next goal is to somehow convert this insecure origin to a secure origin. And since so at this point in time, again I did a lot of attempts to try different things to make it in a secure origin, but I ended up finding only one thing, which is after even reading the documentation, I realized that the local host and the file URIs are considered to be in secure origin because they helps developers to test their setup on the go before even moving to the production. So again, if you so again we are checking the location dot its secure context, which is false. And again, if we set the location dot host name to the to the value of localhost, and if we check the secure context again, it is returning us true. So which means now we have successfully converted a insecure context to a secure context, and so we can request the video permission as well. Now at this point in time, I also try to see, since we have the top window is in secure context, so every iframes which is belonging to about.src docs or about.blank should also be considered in a secure origin. So I try to create different iframes, and I try to dynamically generate all those iframes in terms of the main window to check if we can request the video permissions, but all of the cases were failed. Even also a normal request to get the video permission on the current window was getting failed because I was getting some error which is unhandled promise rejection, security error, this operation is unsecure. So maybe this is the way of protecting the users by the Safari. But then I give up on the current window as well, and I decided to start playing with the in context of a new window. So and this worked pretty well. So again, if we want to look at how the audio and video permission can be requested, we have to initially set the location.host name to the local host, and again we can open a window which says Safari-reader and the local host, and any path, it's not necessary to be a correct path, but anything, because localhost is just a name here. And again, we are creating a video tag to reflect our video, which is requesting the permission in 2 seconds. So as soon as the SVG element or the black circle from the previous, as we discussed previously, is clicked, it will ask you the permission. It will ask a script from localhost will ask you to use your camera, and if you allowed it, we have the video permissions. We have the video permission from the localhost. And you can also create different or use different sort of blob URIs to prompt the user with different or weird origins. Now, as I already discussed, localhost is just a name. It does not require anything or even have the localhost to run in the victim's browser. It is just a name, and that's it. And similarly, we can have the screen sharing permission bypass as well. Again, we have to set the location.host name to localhost and then open any address which belongs to the localhost, and then we can request the screen share permission as well. Similarly, we can look at the notification permission as well, but the interesting thing was that for notification permission, it will not ask you the prompt if you have already given the notification permission to the local host. So this was a plus point for notification permissions. Other than that, I also tried to retrieve the geolocation permissions, but even though we are still in secure context in terms of the new Windows, still I received an error which says the access to geolocation was blocked because this operation is insecure. So this was a trivial problem because only one of the permission is not working and rest of the other permissions was working well. So yeah, I tried again to figure it out, but sadly there was no success at all in finding the geolocation permissions. And so we can also bypass the CSP as we discussed in our initial attempt, that assume if there is any website which has a perfect CSP in place, so it will trigger in normal mode, but as soon as the document is turned into the reader mode, it will not trigger it. So we can bypass the CSP checks using the Safari reader mode. So again, all of these bugs are fixed in August 2020 security updates by Apple, and some of the bugs are grouped into one. So they have assigned to CV's ID. And also the bugs are fixed in a weird way. Now what I mean by weird ways is that they again just make sure to stop the JavaScript code execution. That is it. And rest of the behaviors are working same as it is. For instance, the importing content from child to top or top to child is working as it is. Also, the behavior of most of the behaviors from the location.hostname properties is working same as I just demonstrated. So which means all you need is just another bypass, and if you have the bypass, you can pretty much recreate everything. You can pretty much recreate whatever I presented here. So you just need a bypass. And as always, I always challenge yourself to dig deeper and to come up with different ideas. It takes time, but that's what the challenge is. Do not give up as I did earlier in my initial attempts. So yes, that's it. Thank you, everyone. If you have any questions, please let me know. I'll be happy to answer. Also, you can reach out to me on Twitter. This is my Twitter handle. Also, if you want to look at my previous research, this is the website where you will get everything that I published. Okay, thank you.